Hey everyone, my name is Ben Perez. I'm here with Michelle LaMont, and we are presenting on design pattern, uh, the design pattern observer. We did a little bit of research, and we want to help define this, make it a little more clear for everyone as we get ready to move forward in the class. So we have basically the observer defines a one-to-many relationship. Okay, so with that meaning that when one thing changes, one subject changes, then the others are updated and notified. So an observer represents the variable abstraction, and then the observer component behind the observer is like the component behind the user interface. So it is aware of things that change. So when you click on something, the observer is notified to react accordingly. So let's talk about an example. One example that's really good is auctions. Auctions are really awesome in showing how the observer design pattern works. So we have the auctioneer at the top of the podium there, and then we have all the bidders down below here. And so basically what happens is we know the cycle, right? We know everyone's got their little paddles as far as the bidders go. And when the auctioneer announces something, then the bidders start to, raise their paddles. And when they accept that bid, then the auctioneer will say, I still call a number, let's say 17, for $100, and then they're going to call out the next one. They're going to go in increments that they feel that is being reactive to the crowd. So they'll say $150, $200, and then as they're announcing it, they're broadcasting it to the bidders, and so then the bidders will then react accordingly, and then they will start to accept the bid by raising their paddles, and then that's kind of the cycle there. So the observers are getting that information, and then they're acting accordingly. Yeah.
Just to remind you, so the intent of the observer design pattern is to define the one-to-many dependencies between objects. So when one object changes state, all its dependents are notified and updated. And these are shown within methods in each the subject and the observer. This UML diagram illustrates how this design pattern could be implemented in our HAP application that we're creating this semester. So we would have multiple students represented on the bottom, and those students would be connected to HAC, and they would rely on updates. The updates such as due dates that might be changed or announcements the instructor adds, and maybe it changes to the assignment. And as the subject receives this data, he notifies the observer, and the observer accepts that update, and the update is then distributed to the students. Similarly, the students could check off any completed items, and the hack would update, and the status progress would be updated. So a student would then be able to say, I completed assignment, and hack would check that off and remove that from their to-do list. And so there's an exchange of information there that is used through the method notify and update. And also, since coupling is a degree in which objects depend on each other, the biggest advantage of the observer design pattern is this coupling, because this principle supports a weak or a loose coupling between the objects which interact. So that means that the code could be repeatedly used, and such as like event listeners and methods would be reused in the hack application, providing that loose coupling that's optimal for the data. Also, one disadvantage that we found in this process could be if the observer object is incorrectly implemented, it could cause some performance issues and some irregular, incorrect data, which could be returned to the student or back to the hack. So next, we're going to review some main points that we've covered today. So for summary, for our observation design pattern, these are the basic UML components that you'll see throughout any research of this pattern. That these demonstrate the purpose of the subject object, which is to send a notification to its observers when there's a change in the state. So the subject, you see, contains a notify method, and the observer object contains an update method. So it's important to remember that this is a communication to keep this, to notify of a change in state, and how this would be important use in our hack application. So we would like to, we use the auctioneer because we feel this is a great demonstration on how this works. So the auctioneer, again, is much like the subject. And this is, he notifies the bidders, and this is much like the auction, at the auction, the bidders who would represent the observers. During the development of hack, it's important to note that this observation design pattern would create an optimal weak coupling.
And something really important, I think, to understand is that the observer is the view part of what we're learning about, which is the model view controller. And so that's something that we're not actually going to be involved in changing the view part during these next assignments. But I think the solution that an observer design pattern is to the request is that sometimes you could just be asking, like the example was given, like was to a weather application or website, is like requesting, is there a change, is there a change, is there a change, where the observer would just be taking all of those updates and sending them out accordingly, instead of something constantly requesting to find out if there has been changes. So this is a very interesting solution and quite useful when it's used appropriately.
And finally, here's our works cited references. And if you'd like to find where we found our information, thanks for watching our presentation. And
yeah, thanks guys. Good luck on the quiz.